Let's look at an example directly. For example, you have $1,000 represented by P equals to 1,000. And if you deposit this money into a bank that offers a very generous annual interest rate, say 5%, and we know that 5% written in the decimal expression is 0.05. And if the bank compounds your interest every year, you want to calculate how much money you will have by the end of the first year, which shouldn't be that difficult to calculate. You will earn interest on your principal, and that interest is calculated by 1,000 multiplied by your annual interest rate, 5%. So the interest you will earn will be $50, and you have $1,000 to start with. So overall, your balance will be $1,050. Or it can be calculated by 1,000 multiplied by 1 plus 0.05. 1 represents your principal money, and 0.05 represents your annual interest rate. And if you want to calculate your balance after the second year, don't forget, during the second year, you are also earning interest on that extra $50. Therefore, after the second year, you will have earned 0.05 interest on your previous balance, $1,050, and that adds to your $1,050. So overall, you will have $1,102.50. Or this can be calculated by 1,000 multiplied by 1 plus 0.05 to the second power. And we can continue doing this, and we can calculate how much money you have after 10 years, which is approximately $1,628.89. I said this is a very generous annual interest rate. Or this can be calculated by 1,000 multiplied by 1 plus 0.05 to the 10th power. That should give you a hint that you can calculate your balance after T years using the formula that your balance will be your principal money P multiplied by 1 plus R, which is your annual interest rate, raised to the Tth power. T represents how many years. However, at the time when you were about to deposit your money, what if the bank offered an alternative plan? What if the bank offered that instead of compounding your interest every year, they now offer to compound your money every season? Should you take this new plan? Will this new plan give you more balance? Well, let's see. Again, we're trying to calculate your balance after 1 year. But since the interest is compounded every season, after 1 year, your interest has already been compounded 4 times. Therefore, we need to use this equation to calculate your balance. $1,000 again is your principal money multiplied by 1 plus 0.05 divided by 4. This right here represents an average seasonal interest rate because your annual interest rate is still 5% divided by 4 seasons. And this right here represents how many times your money has already been compounded. In this case, 4 seasons per year. Therefore, it has been compounded 4 seasons already. And that equals to $1,050.95, which is slightly more than the $1,050 that you would have had if you have gone with the other plan, compounding your money every year. And we can continue to calculate your balance after 2 years. And now, since during 2 years, your interest has been compounded 8 times, and you will have a total balance of $1,104.49. We continue doing this. After 10 years, you would have had your interest compounded 40 times. That's 4 seasons per year multiplied by 10 years. And you will have a balance that will be more than what you would have had if you had gone with the previous plan. So now we can again write a formula to calculate your balance after T years, which is A equals to P, again your principal money, multiplied by 1 representing your principal money, plus R over N, and raised to N times Tth power. So this N here is how many times interest is being compounded per year. So for example, in here, interest is being compounded every season. That's 4 times per year. Therefore, you would have a seasonal interest rate of R over 4. And then this term is raised to N times t power again. That's how many times your money is being compounded during the overall t years. So at this point, you probably realized that if your interest is compounded every season, that is better than your interest being compounded every year. That will give you a higher balance. But what if your interest is compounded even more frequently? What if your interest is compounded every month? That's 12 times per year. What will be your balance again after 10 years? So we're going to use this formula to calculate that balance. That equals to P, again, your principal money, multiplied by 1 plus your annual interest rate still stays the same, 0.05, divided by 12, that will give you an average monthly interest rate, and then raised to 12 times 10th power. Again, your money is being compounded every month. That's 12 times per year, multiplied by 10 years, which means that overall, your money is compounded 120 times during this 10-year period. And if we do the calculation, that is $1,647 and then 1 cent, which is higher than the previous two numbers we calculated. So at this point, you probably notice the more frequently your interest is being compounded, the better you will be, the higher balance you will have by the end of a fixed amount of time. So what if your interest is compounded every day or every hour, every minute, every second? What if your interest is being compounded infinite number of times per year? What if n approaches infinity? That will be a case we will call your interest is compounded continuously, and instead of using this formula to calculate your total balance, we will use this formula instead. A equals to P times e to the rth power. Now, in this formula, we know that A is your total balance, P again is the principal money, R is your annual interest rate, and T is the time period you are compounding the money. But what is E? E here is a new mathematical constant we introduce, which is known as the natural base constant. It is an irrational number. It can be approximated to be about 2.718, but it continues on forever. When you are trying to understand this mathematical constant, you probably want to compare this to another irrational mathematical constant that you have already been very familiar with, which is pi. And you know that pi is also an irrational number. It is approximated to be about 3.142, but it continues on forever. And E is very similar to that in this respect. The most important thing is to remember E is bigger than 1. Therefore, if we want to calculate how much is your balance after 10 years again, if your money is being compounded continuously, your balance is calculated to be $1,000 multiplied by E to the 0.05 times 10th power, and that is approximately $1,648.72, which is higher than any of the previous numbers. This is the absolute maximum money you can get with the same principal money with the same interest rate. So now we have introduced the natural base constant E, we can introduce a very important function in mathematics, the natural exponential function, fx equals to e to the x power. As I mentioned earlier, E is approximately 2.718, which is bigger than 1. Therefore, the graph of this natural exponential function looks similar to those other exponential functions with base A that is bigger than 1. It is a continuously increasing function. As you can see, the domain of this function again includes all real number. The range is any number bigger than 0. There's no sense of symmetry in this graph. This graph again has the same y-intercept 0, 1, just like any other exponential functions that we introduced earlier. When x equals to 1, the function value equals to e, approximately again 2.718. This function does not have any x-intercept. It also has the same horizontal asymptote, which is the x-axis. Also, it is a one-to-one function. It will pass both the vertical line test as well as the horizontal line test.